G'day guys. I got a GPZ-7000s come in, and this one here has, as far as I can tell, got a shorted power supply. So I can't really do too much with the camera. What I'm going to do, I'm using the proper part of the camera, and I'm just going to point it at that work mat there, and basically go through how to pull this thing apart without destroying it. So yeah, got to be careful how you do this, but I'll go through and I'll try and explain it as I go. And because I can't see where I'm working, I haven't got a monitor or anything hooked up. It's just the back of the camera is facing in the other direction with the screen on it. So yeah, it's going to be a bit of hit and miss, I suppose. But if I work on the mat as it is there, you should be able to see things. And I suppose if you really are interested, you can zoom in. Yeah, somehow or other. Oh, I heard a door go click. I wonder if that's Dave coming around. Maybe. Dave's got the flu. Everyone's had the flu except me for some reason. Probably because I pumped myself full of vitamin D. And I don't get sick. Last time I got sick was COVID. That was enough. That was a while ago though. Everyone else has been sick. One of the kids got COVID and they're cured now. Like in the last week, I haven't got it. So yeah, I think keeping a high level of vitamin D up stops that. Anyway, I think it's pretty self-explanatory in some of my videos about pulling this thing apart. Don't bust that. And that goes in that bit there. Pull it up gentle. Out that comes. You got to take the screws off there. Don't forget the one under the sticker, which is there. You can see it. So the screws are all out. Undone the nuts. These are why I got these things here. These, I don't know if you can see them. Of course you can. If I have it here, you can. These for undoing the nuts on the front. That one for that one. That one for that one. So comes in handy. Just do it by hand. And anyway, what you got to do on these to get them apart, either small pair of like pliers, not the ones with serrated edges and that'll make a mess, but you got to squeeze these little white things here and pop the board all the way around. And the best way to do the board popping, do it on this side of the board, because there's no components around here where these white things are, and if there is, just do it on the other side of the board. If there is, well, there's one there. Here, there is one, but it's very close to that IC. You don't want to make that screwed. So do it this side. Doesn't matter which side you pop this out. Just pop these away from the components. See, that's close to components. Do that one there. That one is there. That one, you can do it either end. It's a bit of surface mount there, but just be careful. There's one chip resistor and a chip capacitor. Actually, I didn't bother putting the chip capacitor on because it's not there, and it's just got smooth solder pads. It was never there. So when you get that and work on this, I've already done a few of these. I've got one more to go here, and I will just pop this. If they're hard to pop, I'll show you a trick. Careful when you do this. Right, there's no components under there. There's no components here. Get your pliers, cutters. Get cutters. Very gently. Don't cut. Don't press. Right. But what you can do here is you can just rest it on the white like that. And just pop it off like I just did then. Don't put a lot of pressure. All you're doing is using the white thing as a leverage point and onto the edge of the board and just lever it off. Don't do anything drastic. Anyway, this is what's under the board. That's one of them. You can see it's a whole heap of heavy, big, large ceramic capacitors on that side of the board, some connector strips. But this is not the bit we're interested in. We're interested in this, and I suspect it's this capacitor here. So what I'll do, I'll just get my multimeter on beep, and I'll just beep him out and make sure that I'm on the right path. That is, as far as I can tell, a short circuit. So he has to come out. Now, when you're going to pull any components off, where they got this, they've actually upped their ante. They're not using hot melt as such anymore. This glue here is that's not glue, but this glue here on the components, what they do is they glue down the tall components so vibration doesn't make them fall off the board, which is a damn good idea, right? So you got a lot of parts, and on the capacitor here, they have a whole heap of glue around it. Under the glue, there is surface mount components. You can't go in there like a bull in a china shop and pull this up. It will pull the parts off the board and wreck the board. If it pulls it through all the way to a through plate and they're a blind through plate, you're going to have a hard time fixing it. So be careful. The trick is when you're removing this glue, isopropyl alcohol. It breaks the adhesion when it gets under. It's a slow process, but this will not hurt anything on the board. I'll just blob it around there, a fair bit on the board. All you want to do now is get something which is a bit of a pokey object. Tweezers, good enough. Let's put my 4-eyes on, get right in here, and without digging right into it, try and just lever it away from the component. And he's stuck like you got no idea. It really is stuck. Now, if it's that stuck, this is where you've got to be careful. You can't push in. You've got to be gentle. Okay? Look, I think this really takes a knack to do. But I've got a rough idea where parts are, and I know where I can push and where I can't. I'm right next to a SOT23 component there. All you do is get this stuff to move a bit and just be very careful. So there we go, we've got some movement. And off she's coming up. If you can see that, it's coming up. Okay. So it's a big job trying to get a capacitor off the board, and that's not the end of it either, just doing this. The board has multi layers, and if that capacitor is stuck down and soldered into the multi layers, it's going to be really difficult. I'm just working above some surface mount components. Got to be careful, go slow, and the isopropyl should break the bond bit by bit like this, and off she comes. So always check it to make sure there's no surface mount components stuck in the glue. Well, this it's very rubbery, this stuff. It sticks good. It sticks a million times better than hot melt glue. I don't think it's a hot melt glue. It could be, but it's very rubberized. Whatever they're using, it's quite good. So now we've got this capacitor here. How are we going to get that off the board? Now we're going to check it out. We look here, and I don't know if you can see, you may have to zoom in. But one there, one there. You can tell these have been hand soldered. These are not machine soldered. So this is going to be very interesting to get this out. It's right next to a couple of SOIC 8 components. So, yep, that's a current monitoring or sensing resistor for the transmitter, and those components. Oh, guess what they are? I'm not joking, right? They're AD797s. I'm not joking. Right there, two AD797s, like you find in the front end of the other detectors. So anyway, if we do cook those, which I hope not, because you know what? How are you going to get that out? It's difficult. I'm going to do this with a single soldering iron. I'll never be able to get I can't use anything that puts a lot of heat in there. It'll just wreck it. This is where you've got to be careful, and this is why sometimes I use the bigger tip. Not all the time, but what I'll do, I'll put my iron up to 700 degrees, which is about 380 Celsius, 700 Fahrenheit. It's really cooking, but I've got to do this. I'll never get it out otherwise. This board is a massive sucker of heat. So on with the 4 eyes, and you can see the tip changing colour. But yeah, I'm touching that. There we go. We can get that one to flow. This one here, I think this must be the ground side. It is absolutely obnoxious to get some heat into that. God, it just sucks it up like no idea. It's very cold here today. It's probably 2 degrees outside, and probably I should. Dear me, got a dry throat. I've just been in here for ages without anything to drink, and anyway, what I'm going to do, I'm going to heat this up and put a lot of heat on it, and just it's going to take a lot of heat. I know it's going to take a lot of heat. But what I'm doing, I'm just pushing on that capacitor to see if the leg moves, but I'm not forcing it. If you force it, it rips the through plates. You'll be absolutely go buy yourself another detector. Right? This is very, very hard to do. Look, you got to have the knack for doing it again. You just got to know the pressure. I'm putting about, I don't know, 50 grams of pressure on that capacitor, pushing it sideways and just doing it and feeling it to see if it's got any give. But it don't want to move. You cannot solder suck these boards. It will not work. So you got to do it like this. You feel like bringing out the 80-watt Burco soldering iron, but I'm not going to do that. I just have to get the heat in there. See, it's melted the solder on this side of the board, not a problem. I can feel it move about 1/4 of a millimeter. Okay. It's moved a 1/4 of a millimeter. I'm just going to clean the iron up a bit. And I'm going to put the flat part of the tip on this now to give it more heat transfer. I've got to actually cook through those through plates. Get the heat down. Difficult. It's very, very difficult. That's why I leave the hole flooded with solder. You can't do this any other way. It won't do what you want it to do. moving a little bit now. Okay, I don't want to tip it over on too sharp an angle, so now I'm going to do the other side. If you have a look here, I'll show you what I've done. If you can see that. See the capacitor, it's leaning over. Now, that is very gentle pushing, not hard. So when you get there, it's going to cause rather than a vertical force coming out, you're going to have lateral force, so that's why I've stopped. You can't fight lateral force and vertical force trying to get this thing out this way. You've got to do it slow and careful. Now I'm going to push the other way on the other side and get in here. There's a little surface mount component there. God, this is going to be difficult. It's right next to those AD797s. We're going to see how I go. And this is the hardest one to do. Worst case scenario, I could take out the take the SOIC components off the board and put them back on, but that's just going completely overboard. And she just fell out. Lucky it had short legs. Okay, that is 5,600 microfarad capacitor, 6.3 volts. And I'll just check the board to make 100%. I'm pretty sure it's that cap. It was really low ESR around it. So if we go on there and there, no, that's fine. We're open circuit. Well, about 1,000 ohms. It's good enough, close enough to an open circuit. So there's your capacitor. Where the white colouring is here, that is the negative. Now, I've done this and I've checked this and made sure that this capacitor is very critical, as in you don't want it to dry out and become a bit rubbery. Good, that's a word we use, that it won't hold its capacitance properly. It's probably 5,600 is probably okay, but I went and got some really high quality low ESR capacitors. I can't remember the brand. It's not written on there, but they are really, really good. I got these from Mouser, and you can tell they're good because they're heavy. And what these are, instead of being 5,600 microfarads, they are 10,000. So we're nearly double the capacity, which it should help will hold the supply rail here far more stable. If you can see where it is, it's right into the coil driver, into the driver stage. And around here, you want low impedance, high value capacitors. So here's where it gets interesting. There and there is all full of solder, and I have to get it out. Now, like I say, you cannot solder suck these. It just will not budge in a million years. So the trick is with the iron very, very hot, which it is, it's steaming, I will get some desoldering braid, which is this stuff here. I suppose you really want to look at it there. I go through a lot of this. The trick with this stuff is that when you buy it, the resin that's meant to be on the wire and protecting it has all gone to God in most cases. I've bought it and it's meant to be loaded with resin. There's no resin on it. So what I do, I get this stuff, and in this, I got new stuff, but I'll just use the old stuff here. Just clean that up on the end there. Leave a little bit because it helps tin it and get it going. But what I'll do, I will stick it in here and I will dab some resin on this. I don't want a lot, it'll go everywhere. Then I'll have to clean it all off. But just, you probably can't see, but it's got resin on it. So we'll get this, and I'll turn this around this way because it has a lean. We'll get it leaning. I hope it doesn't make life hell for me doing that. It will. I was just trying to give you guys a better view, but how about we shove the screwdriver under there? And there goes the capacitor. So I'll stick that there. I do want it to lean down a bit, but it wants to sit up on its wires, of course, and everything else. So stay there. Clean the iron, get all the gunky oxides off it, because it will generate lots of oxides when it's at extended high temperature. So we get in here and we make sure that we go onto the right spot. I'm going to have to work like a bit of a bent person doing this. Get out of the way, you. There we go. I'm going to do the one that's the easy one first. Got it straight away. The next one's the hard one, because that is the negative, and the negative goes through lots of layers to ground. Well, it is ground, but yeah, this can be a bit of a bugger. We'll try it. I might have to have a couple of goes at this. I can just feel it sucking the heat out of it. And you probably noticed too that the capacitor I've got, the new one, is taller than the old one, but I've already done the measurements. It does fit. It won't cause any issues. So here we go again. It's really slow to melt. It really is. The other trick you can do is try and heat the leg of the capacitor and push it through dry. That is, if it sticks, you can end up with a real mess. But we'll see how we go with this. This braid is getting red hot in my fingers. Okay. It just wants to act like the proverbial I'm not going to do what you want thing. So what I do here, get a little bit of resin. This is resin's dried out. I just put acetone in to make it wet up a bit. But we're going to put a big thing of honey. Get on there. Okay, and it's a fair whack on there, I tell you. This will help keep the heat around that joint. And hopefully we'll get this grunt on it and see if we can make it jump up onto the wick. Don't want to breathe that in, yuck. Okay, well, I've got rid of some. You can see it's jumped up on. Okay. Now, there is another trick to this if it doesn't want to budge. Yeah, it's right up there. And the thing is, if they've put these boards together with non-lead solder, which they're basically non-lead solder, you can get some special solder, which is a low temperature melting point solder. And what you would do is you would try and mix it with the stuff they've used anyway in here, which has got a high component of tin. But just heat it up. Try and get the solders to mix, which I've just done. It sounds terrible, doesn't it? Putting more solder onto something you're trying to remove the solder from, but this can work, and it has. I'll bend that up out of the way because otherwise it'll grab things I don't want it to grab. Okay, there we go. We'll see what happens now. Move it up a bit. It's coming because it's sucking up the stuff and the hole's flat. So we'll just see. Yeah, it's just making a divot. It's not really taking. Let's chop that off. Get some more of this fluxy stuff on there, resin, whatever. We'll give it some more heat. Eventually it'll come. Let's get the oxides off that. And we'll just let this heat right up. I should have done this as a live feed, shouldn't I? Okay. A little bit more of a divot. God, you feel like opening a bottle of champagne when you get the solder out, I tell you. Uh-huh. Yeah, it's a bit tedious. It's going to be a real, you know what. Okay. Can I do this? I'm going to have to do it very, very. Hang on, have I got them here? It's nowhere known. Like I say, you can't solder suck it. It's impossible. But what I'm going to find, if I can, I've got some sewing needles, and like I say, I do have some. I bought them, so I use them on the probes of the multimeter, where I can stab things and get measurements. And of course, it's not something that I would use all the time, and thus, you know, I should have a drawer with sewing needles written on it, but I don't, and I have absolutely no idea where they are. And in this place, if I go trying to find them, I'll probably spend half an hour. So I'm not going to do that. What I'll do, I'll be very, very clever and steal one off my LCR meter. And then what I'm going to try and do is I'm going to stick it in the where the negative is on the capacitor, and I'm going to apply heat and try and poke it through. Now I've sucked off all the solder, I can't really get any heat into it. Should be able to still. Come on, come on. You got no idea how difficult it is. I don't want to put solder in the other side because this is halfway down, there's no solder there. But if I hold it like so, and I'll try and get right in there. It's got to heat up all those ground planes. Oh man, my God. Should go through. I'm going to have to do the old trick, and if I want to try and get, look, it's stepped into the solder, it's getting a little bit soft. I think it comes down to putting a bit more heat on it again. A bit more of this. Here we go. See how we go this time. All I got to do is make a hole. Once I've got a hole there, there's a lot of things we can do. Okay, back in there. Now that'll flow really, really well and generate more heat down through those through plates. But I wish I knew how many layers this board was. It's probably 5 or 6. Come on. Come on. Come on. Come on. Come on. I'm getting on top of that. There we go. It's coming through. Okay. The trick is, when you take the soldering iron away, keep wiggling it so the solder doesn't stick to anything. Okay. I've got a hole there, but it's probably not big enough for the capacitor leg. We'll find out. Now, these things come taped on a reel, and when they're taped on a reel, you really need to give it a clean, and otherwise I'm going to pull the remnants of the glue and cardboard off the legs. So I'll just give a bit of isopropyl on this old sacrificial face washer. Usually I would use acetone, but I just can't be bothered refilling my bottle. There we go, nice and clean. Chuck that over there. The legs are clean. Make sure stripe negative. Let's see if we can get this through. I know I'll get that one through, but this one here might be an issue because it's a very small hole. I don't want to force it. See how I go. Okay, it's bumping into the solder. So what I'll do, I'll heat it. You notice when I stop heating it, it grips straight away. So as long as you've got one hole that's moving, we'll get there. We're nearly down. Keep the heat on. Don't push it without the heat on. You'll end up with a big mess. So we get there. I'll look there. Okay. I'm going to push that capacitor as hard as I can. Okay. We've got him through after all that. There's that nice big 10,000 microfarad capacitor. So what we want to do now is just tack the positive leg. Just tack it. Don't go and float tons of solder on it. I'll show you why. Okay, she's tacked. Then push it on the positive side. Here we go. See it wiggle a bit. Well, I'll keep the pressure on, hold it down. This will stop the thing wiggling around and vibrating off the board in the future, but we're going to probably put a bit of adhesive down on it to keep it there. And this one here, same thing. So there we go. We have the legs sticking up in the air there. And what I'll do, I'll just put a bit more because it's nowhere near stuck properly. So we'll get this one here. Give it a fair whack of heat. I'll just keep my finger on it just to make sure it stays down. It flows down that leg. heat the component leg up because that'll take the solder down the hole. Here we go. And this one, the same thing. Give it a big dose on the leg. Hold that there. Yep. She went down. Good. You know when it's working good, the capacitor gets a little bit warm. So that capacitor that's hard as, it's locked in there. Now the careful cleanup. Always with these type of boards, be careful. Make sure you're not going to cut something you don't want to cut. Get in fairly close to the board, make sure there's no other surface mount components around it touching anything. Snip, off comes the leg. Same on this one. I'll just change the angle a bit. I don't want to cut the AD797, sorry, not 793. Clean up the iron a bit. Just touch up those pads. Even though they were probably like this because I hand soldered, that one's okay. And this one here, my God, it's just a heat sponge. I know it took it down, but yeah, that's better. It just needs a hell of a lot of heat. Then I'll turn my iron back down to about 600 Fahrenheit, or just over 300, 330 or 40 Celsius. And that capacitor is in, which is good. So I'll just get my meter. Put it back on. It didn't turn on. Where are we? We are there and there. Yep. It just went up to 1.8, and on that way around 1.8K it was. We're swinging around 1.8, a little bit over. So that is in. Double check everything. You know, even to the point of saying, did I put it in the right way around? Yes, I did. But you know, if you're talking and concentrating on other stuff and not concentrating on what you're doing, there's every chance you could really balls it up. You don't want to stick the capacitor in the wrong way around. It'll probably work for a bit. You'll hear the almighty explosion as the capacitor heats up and blows its guts out everywhere, because that's what they do. They go off like a bomb. When I was a kid, we used to get capacitors because they didn't have vent caps on them, the old ones, and we took them up backwards across car batteries, and they used to go off like detonators. So, yeah, I just put a bit of isopropyl on this. I've really cooked that resin. Might be hard to get off. That's all right. Work on it. Got plenty of resin everywhere. It's all over those AD797 sitting there. So I'll just say this, that you know that Minelab products overall, and I'm talking about the design, the circuitry and quality, is absolutely outstanding, because AD797s, even in bulk, are not cheap components. You could put something cheaper in there, right? You could, and it will still work. The detector will work fine, but just seeing that they've gone for a very low noise option in this part of the circuitry tells me that they just don't muck around on the quality. They just don't. It's really top notch. You know, you don't find, you know, sort of knockoff components in there. It's all genuine stuff. So let's make sure everything is nice and clean and decontaminated. It looks beautiful. Looks like the day it was made. So there you go. That's how, if you can see that, you probably need to zoom in or something. Yeah, that's where those little silver bits there. We'll get my pokey screwdriver, and that one there and that one there been redone, and she's all nice and polished up. So yeah, just check around and have a really good close look to make sure you didn't put solder dags anywhere. If there's anything suspect, what you want to do, get your multimeter and just make sure. Even, it's going to fall off the bench. Get back on there. Even if you're working near the surface mount capacitors and stuff like that, just make sure there's no continuity. Check the little tiny surface mount. No, she's right. Yep. It must be above other parts of the circuit with other bigger capacitors. Little tiny capacitors like that do not make this beep. But it must be in the circuit somewhere. That's fine. Fine. I can check. I know the pinouts on these op amps, and I know what I should see between inverting and non-inverting inputs. So we'll just have a quick squeeze. Yep. If you put on a meter on diode range, it'll say 1.037 or 38. That is how you tell AD797. That's the back-to-back diodes, or should I say the parallel, well, they're sort of anti-phase parallel across the, if you want to, how would you even say it? One's one way and one's the other. They both go across the pins. One diode has the anode connected, the other has the cathode connected. On the other side, it's the other way around. So, yeah, it limits the voltage going across those input pins to under roughly, 0.6, 0.7 of a volt. So that's that one. Just check, because we did put a bit of heat around there. Don't do that. That was me slipping with the pin. Very strange. Very strange indeed. We've got 7 ohms across that. Let's hang on a sec. Make sure both of them are AD797s. I think they are. No gunk on them, so I can't read them properly. But that's pin 1. Oh, hang on a second. I know what's going on. Yeah, 0.07 of an ohm, I guarantee you. Yep, and there. Yep. The inputs are connected across the current sense resistor. Had me going there for a minute. I'm going, bloody hell, well, we've got a short circuit. But no, the inputs on this, they've put the AD797s because the transmitter in this design of detector has to be ultra stable in its transmit when it's transmitting. It has to hold a constant voltage. And if it is any movement, it's going to introduce noise. That's why I wanted to use a bigger capacitor here, because that should be able to help in that department. Nothing wrong with putting a bigger cap there. That is the way to go. And yeah, this one here doesn't go anywhere near that. Nah, it's part elsewhere in the circuit. But yeah, if I have a look at here on the inverting input, it's 0.07 there, 0.69. There's not much in it. There should have 7. No, sorry, that one there is 000. That's where it's actually connected to, and then on that side it should be a little bit extra. But we'll have a good look around this, make sure that there's nothing has gone anywhere else. Nope, nope, nothing. It really is wise to check everything. Yep. Yeah, it's a bit of stuck resin, which I'll just knock it off there, and it's stuck beside it. But yeah, you can't be too careful. If you did this wrong and you had something bridged across, or something had gone across, or something untoward you haven't picked up on, that could be a real issue when you turn the power on, because it could go up in a big puff of smoke. So just really carefully check, because everything is relatively small. Yeah, that looks all right. That looks good. Okay, fine, fine, fine. Just checking everywhere where I had that iron that it didn't do something that I haven't noticed. I haven't even touched the other legs on the ICs. Nothing's moved, so it should power up. It should work like a charm. So the way of putting it back together, you have to line up these row of pins here and that row of pin there. Don't get it round the wrong way. Not that you can, because you can know this connector here goes in the slot. So the trick is look sideways into it. Get a rough, those little plastic jerkins. When I don't know the name of something, I call it a Durkin, right? So be wary of that. We've been doing that for years. You know, the Durkin. Can you get me the Durkin? You know. So okay, lined up, lined up, lined up. Get in there. So it lines up like so. I do one side of the board first because the pins are in. It's not going to cause any issue. You could be pedantic and do it here, do it there, and do it there, but it doesn't make any damn difference. There, middle one, that one. Just double check everything, and that is how this board is meant to look. Except this has got a dirty big whopping storage capacitor in there as a replacement. So yeah, you can really see the difference in height. You've got components there now. You can't really see that. Um, it's got legs on it. I can't really do a comparison, but you saw before, it's a lot bigger, but it does fit in there. And the only thing, if you're going to have an issue, to hit on these top connectors. But if we plonk that in there, like so, trying to get the line up's an interesting thing sometimes. It's got a little notch on the bottom it's got to go into. There we go. So you can see there it's very, very close to those connectors. If I actually had this in and pushed it all together, it will go in. There's no real problem. I'm going to put it around the right way, of course, so I'm not thinking. So yeah, if you can, I'll just wiggle it into position so you can see that it does it does go back in. Please, please. Okay, you got to get these to line up. Else makes life difficult. You got cutouts, notch cutouts, and I've always noticed that when you put them back together, this one here wants to stick up in the air. It always wants to do that because I haven't put it in the little holder there. So if I poke that in there, hang on a sec, bear with me. Okay, I'll do it the old-fashioned way. Get down. Okay, yeah. You just got to get this gadget, the little clip for the ferrites. Anyway, it's basically, there we go, got it in. So clip for the ferrites, that's how the ferrites go in. As you can see, I'm going to wiggle that around a bit to get it in. But yeah, the connectors are in, and if you, well, I'm going to twist that one a little bit. Come on, there you go. The connectors are in, and you can see the connectors. It's jumped into its little housing. That's where it's got to clip up. Fine. As you can see here, if I get the end of that, say, and there you go, I can stick that above the capacitor. So there's no height issue there, and we've got better capacitance voltage reservoir for when this thing draws current. It should help it, and that's that. This thing here goes back in there, and yeah, I would definitely test this, but the customer didn't supply a battery, and I've got my own battery, and Dave's got it because Dave's got a detector. Someone he wanted to test for someone, or they sent it in without a battery, so I have to get my battery back. I mean, I could hook it up on my power supply, but it's not the same. I want to use the battery, and I haven't got any others around with batteries. People tend to send detectors in without batteries, except a couple of 6000s I got in came with batteries, which is good. So, but it won't fit the 7. And yeah, I don't think I've got anything. There's probably another 7 out there, and I better go and have a check, see if I've got a battery. But believe me, this will work. It'll work fine. No problem with it. You know, I know where I worked. I know what I did. I know the measurements. I, had that small issue where I thought that, the inputs were a very, very bit low. That would not be normal for an op amp. But then I had a look, and it's, all in conjunction with that current sense circuit. So that is fully logical, and that gets me off the hook in that part of it. So yeah, what I should do, I really should do something about getting a camera and having it up here somewhere, and some monitor hooked up as well, so I can see and make sure things are in focus when doing these. There's a heap more stuff about these detectors I want to do, make some videos about, little things you can do yourself. And yeah, like I was saying on that previous 6000 video about the Mylar, have a look at this. This is what I was saying to Adam, who had his 7000 turn off on him. Yeah, you're saying that, oh, I'm probably going to hold it down here. That Mylar, there is nothing protecting those data wires, as you can see, and that might be worthwhile painting in the carbon paint. Just be careful that the carbon paint adheres to the Mylar, and it doesn't do anything weird, and just on the here, just track it down to the negative battery terminal. Don't go anywhere near that header there, the pins there. Just take it to the level of that stiffener on there. That's what they call it, by the way, the stiffener. Yeah, you could make a joke about that, but I'm not going to. Yeah. Yeah, that's that. Anyway, any more I do on that's just waffle for the time being. I've got to get my battery. Anyway, I'll get round behind here, kick the tripod again, and turn it off. I hope that was some sort of education. And yeah, well, it just shows you can pull these apart and you can work on them. If you're competent, don't be scared. But if you're not competent, and you flip burgers for a living or lay bricks, don't get into the electronics. That's all I'm saying. If you know what you're doing, if you can fix TV sets or computers, maybe you have a good chance of doing your own repair work, I think, on these. But you got to know what you're doing. You can't just go and balls it up, basically, because it'll be a very, very expensive mistake. So anyway, gentle, just go by feel. If it doesn't, you feel like you're forcing, don't force it. That is really the idea about this sort of stuff. Don't force anything because it'll bite you on the backside. No joke. Anyway, yeah, I would have shown it at work in the room, but I got a coil. I have the display, and I don't have a battery. Oh well, no worries, catches.